Welcome back. In this video, what we're going to do is we're going to explore the concept of velocity and acceleration as it relates to a particle that's moving along a coordinate line in a position function x of t. So if x of t is the position function of a point P that's moving along a coordinate line L at time t, then the velocity is the derivative of that position. The acceleration is the second derivative of that position, or the derivative of the velocity. And then the speed of the particle is the absolute value of the velocity. And one of the concepts that we get confused on is the speeding up, slowing down thing. A particle is speeding up if the velocity and acceleration have the same sign. In other words, they're both positive or both negative. The particle is slowing down if one is positive and one is negative. Doesn't matter which one. In my first example, I give you this position function. And so the velocity, I asked you about the velocity acceleration at 1, and then it's speeding up, slowing down. So the the velocity equation is given to you as 3t squared minus 24t plus 36. And so the velocity at 1, I got to be 15. The acceleration is the second derivative, which is 6t minus 24. The acceleration at 1, I got to be negative 18. And then the last one, is it speeding up or slowing down? It's slowing down because these have opposite sides, so slowing down. In my second example, this time I'm just presenting it a little bit differently. This time I'm looking at a graph, and give you I didn't give you a position function. I'm looking at a graph, and this is the velocity graph, so it's a derivative graph. And so we want to know when the object is at rest. It's at rest at 0, at 30 minutes, and then back at 55 minutes. What's the object's acceleration at t equals 20? At t equals 20, I'm going to be right here. And at t equals 20, the acceleration is going to be the slope of that line. So you need to just choose any 2 points along this line and find the slope. So the acceleration at 20, the points I used 15, 60, and then I used 30, 0. So 15, 60, and 30, 0. And when I found that slope, I got negative 4. And that would be, the way this is set up, it would be in meters per minute squared. And then finally at t, in part C, at t equals 50, is the particle speeding up or slowing down. At t equals 50 right here, okay, I'm at 50 right there. So the velocity would be negative, but the slope of that line is positive. So that means the acceleration is positive, so this is slowing down. And then finally, sometimes you see things like this as well, where they give you a velocity that is a little bit harder to work with, and they expect you to use your calculator. So we put that in our calculator, and in this case, I'm going to graph it in my calculator, and they gave me a domain of 0 up to 3 seconds. So I went ahead and did that, and then I asked you questions about it. What's the velocity at 1? This is a velocity graph because that was a velocity equation. So if I want to know the velocity at 1, I just go second calculate a value at 1. And that velocity at 1 is negative 1.548. The second question asked me the acceleration at 1, so that means I want to find the derivative at 1. So the sixth one down is derivative, and I can tell it at 1. And I found the acceleration at 1 to be negative 2.432. And then they want to know if it's speeding up or slowing down at 1. Since these have the same signs, this is speeding up. All right, so velocity, acceleration, position functions is a concept that we're going to work with quite a bit throughout the rest of the year. So hopefully you have a good understanding of this. I'll clarify in class anything you don't understand.